Hello everyone. Out exercise 1.2.11 and 1.2.13. So question number 1, 11. The square of every real number is non-negative. Write this in symbols and negate it, and then write the negation in words. So we will write this using quantifier symbols first. Square of every real number is non-negative. So your set of contexts are here real numbers. So if I call this statement as statement number A, then how will I write it using quantifiers? Every. So universal quantifier. For every x in A, its square has to be non-negative. That means its square will be bigger than or equal to 0. Non-negative meaning either positive or 0. Right? Now we will negate this. So negation using quantifiers will be how? As we had seen earlier, existential turns to universal and universal will turn to existential. This will happen. So its negation will be there exists a real number x in A. This is R, sorry, such that x square is not bigger than or equal to 0. That means x square is negative. Negation of x square not bigger than or equal to 0 is x less than 2. Right? And now we have to work it out in plain English. So there exists a real number whose square is negative. That will be its negation. There exists a real number whose square is negative. So this is the negation in plain English. I hope that is clear. Exercise 1.2.13. F is a function from x to y, be a map, and y and z be any 2 points in y. Write the following statements using quantifiers. Y is in the image of x. So y belongs to image of f. What does that mean? There is a point in the domain of the function such that f of that point is y. So there exists a point x in x such that f of x is equal to y. So there is a point, this is your domain x, this is the domain y, and let's say this is the image set. Okay, so for y to come in the image, there should be a point in the domain which is related to that point y through the function. So there is at least one point in x in x such that f of x is y. Now z is not there in the image of f. So it's basically the negation of the previous one. When will you say that z is not there in the image? When you take any point in the domain here, no matter which point you take in the domain, none of them will have the image y. So for all x in x, f of x will not be equal to z in this. That's why z will not come in the image. Okay, so that's how you negate. That's how you write these statements using quantifiers. Right? Thank you.